All right, let's talk about inscribed angles. This is section 12.3. The definition of inscribed angles. An angle whose vertex lies on a circle and whose sides are chords is an inscribed angle. An angle whose vertex lies on a circle, like this picture right here. B is the vertex of angle ABC, and whose sides are chords. Sides are chords. It's said that the angle is inscribed in the circle, or it is an inscribed angle. The inscribed angle theorem tells us how to find the measure of an inscribed angle. The measure of an inscribed angle is half the measure of the intercepted arc. So, for example, well, first of all, you remember central angle. If this central angle is 60, then the measure of the arc is 60. Central angles and arcs are the same. With an inscribed angle, the angle is half the arc. So if the arc is 60, that means the angle is 30. Inscribed angle is half the measure of its intercepted arc. Let's do an example. What are the values of A and B? Well, B is an inscribed angle, and it is half the measure of the intercepted arc. The arc is 56, so the angle would have to be 28. And then to find A, this angle that I'm drawing here is 52, which means its arc is twice that, so the arc is 104. And part of the arc is 56, so you would subtract that to get the measure of A. A would be 48. A couple of corollaries or kind of subpoints to the theorem, to the inscribed angle theorem. Two inscribed angles that intercept the same arc are congruent. Now that makes sense because if this inscribed angle intercepted that arc and that arc was 50, well, the angle would be 25. And if this angle intercepted the same arc, well, the arc is still 50, so the angle would be 25. Here's another corollary. An angle inscribed in a semicircle is a right angle, and that makes sense as well, because if you inscribe an angle in a semicircle, that means the arc is 180, so the angle is half of 180, which is 90. So an angle inscribed in a semicircle is a right angle. And then the third corollary is the opposite angles of a quadrilateral inscribed in a semicircle are supplementary, or they add up to 180. Now this also makes sense. Just think about it. We'll call this angle A and this angle B. Well, angle A is half of its arc, and its arc goes right there. The green arc is the arc for angle A, and angle A is half the arc. Angle B is half its arc, and so its arc is right here. The red arc is the arc for angle B. So angle A is half of the green arc, angle B is half of the red arc. Well, if you add the green arc and the red arc together, you get a whole circle, which means the green arc plus the red arc adds up to 360. And so if the measure those two arcs add up to 360, and A is half of the green one, B is half of the red one, that means that when you add A and B together, you're going to get half of 360, which is 180, and that's what that corollary says. The opposite angles of a quadrilateral inscribed in a circle are supplementary. What's the measure of each numbered angle? If you look at A, angle 1 is inscribed in a semicircle, so angle 1 is 90. It's a right angle. If you look at B, you can see that this angle is 43, which means this arc right here is twice that because that angle is inscribed, so this arc is 86. Angle 2, look at that, same arc. Angle 2 is also 43. Two inscribed angles that share the same arc are congruent. All right, we're going to find the missing angle along with the question mark. If YZ is 110 and ZX is 146, you add those together, you get what? You get 256. So the rest of the way around has to be 360 minus 256, which is 104. And since that's 104, this question mark is half of 104, which is 52. We have a quadrilateral inscribed in a circle. Like we said a moment ago, the opposite angles are supplementary, which means x is 72 and y is 92. Now these are inscribed angles. We're going to move this inscribed angle and see what happens. So if I bring this inscribed angle down like this to where I make one side a tangent instead of a chord. We did have two chords, so we had two chords right here. And you see this arc right here, the size of that arc. And if I bring it down here, and instead I have a tangent and a chord, so now it is this arc right here. Well, it's no longer a let's see if this will work. I didn't draw them very good. It's no longer a inscribed angle, but that arc still stayed the same. It's an inscribed angle here. Now it's an angle that's formed by a tangent. Let me get it right. A tangent and a chord, but it's just like an inscribed angle. So the if the arc, say the arc is 80, well the angle would be 40, still half the arc. That's what this theorem says. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. It's not an inscribed angle, just like one. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So in the diagram, AC is tangent to the circle at B. If the measure of BED is 214, BED, what is the measure of angle DBC? So if BED is 214, that means this is 107. So we really can find this one of two ways. That's 107, so the angle right next to it, DBC, is 180 minus 107, which is 73. The other way to find it is if BED is 214, the rest of the way around the circle is 134. It's not 130, 146. There we go. 146, and so you have to take half of 146. That is 73. Get the same thing both ways. On this one, that's 133, which means this arc right here is twice that. That arc is 266. Next to the 133, this angle is 47 because those two have to add up to 180. And so this arc is twice the 47. It's 94. Let's see if that makes sense. These two right here, you go all the way around the circle. 266 plus 94 is 360, so that works.